Hey everybody. So the goal of today's lesson is to be able to tell the difference between a linear pattern and an exponential pattern. All right. So we're going to be able to tell this difference both graphically and also quantitatively in a table. All right. So let's get to it. All right. So here we have, I have three tables for you. All right. And in these examples, we have some outputs that perhaps aren't the nicest outputs, right? And we have some kind of complex x's. So this is not your regular 0, 1, 2, 3 x's and y's. Okay. So the first thing that I want to check, all right, the first thing that I want to check with my x values is in order to be able to tell a pattern. Well, the pattern usually lies in the y values, but we need to make sure that our x's are constant. All right, constant. All right. In other words, we want to do something like 0, 1, 2, 3, and not something like 0, 5, 20, 100, right? We don't want x values at random. We need to make sure that they're constant. So when I look at 5, 19, 33, and 47, I see that my x values are actually going up by 14. So they're constant. That means that I can look at the pattern of the y's without any reservations. I don't have to worry about the x's being randomly scattered. So I can really just look at the pattern of the y's. So here I go. So my y's go -1, -6, -36, and -216. Now I can pretty quickly roll out linear. All right, here's why I'm going to roll out linear. This is not a linear pattern. If this were linear, then to go from -1 to -6, you go basically down 5, right? Then to go to the next number, I would have to go down 5 more, which would be -11. But look, it goes all the way to -36. And then there's a huge jump to -216. So what I discover is that you're actually multiplying in between terms. You're actually multiplying by -6. All right. So, not -6, by +6. -1 times +6 is -6. -6 times 6 is -36. And multiply by +6 again, and you get -216. So therefore, this 6 is what you would call a B value, a growth or decay factor, right? Meaning that this first one is exponential. All right. So that's that, exponential. All right. Let's look at our next example. All right. So once again, I've got x's. They might seem like they're scattered, but actually they're not. -22, -18, -14, -10. That's actually a constant pattern, right? They're going up by 4. So once again, I can take a good look at my y values. So, all right, to go from 8 to 12, well, if this were linear, then that would mean that I added 4. And then to go from 12 to 24, I added 12. So between linear or exponential, we're going to go ahead and rule out linear. All right. So now let's just check for a growth factor. All right. Let's check for a growth factor. All right. So with exponential, we should be able to tell if the numbers are multiplying by a factor. So to go from 12 to 24, I'm multiplying by 2. Right. I'm multiplying by 2. To go from 24 to 60, did I multiply by 2? No, I did not. So this one is neither linear nor is it exponential. All right. Again, from exponential, you're going to multiply by the same amount or divide by the same amount every time. All right. So that one is neither. And let's do one more example. All right. This last example, once again, my x's are constant. They're going up by 4. So no worries there. They might look a little scattered, but notice I go from 0 to 6 to 12 to 18. That is very obviously a +6, right? It means that you're going up by 6 for every 4 that you go up, right? So this is +4, right? And this is +6. Your average rate of change, you could say, is 6 over 4 or 3 over 2, all right? But notice how that is a constant rate of change. That would make this guy linear. Now, one last item. So we got exponential, neither, and linear. One last item to talk about is this. So what do these really look like? So if you ever put a table manually into Desmos, you can actually zoom out, all right? And you can see that, hey, that first pattern was actually, it looks curved. It's exponential. This last pattern falls into a line. It's linear, all right? And that shape helps you see, all right, if it's linear or exponential.